I get what I
Yeah, I think it was one of the little things. There were points that you can get. I can't remember.
I mean, I wrote you an entire story. So.
Oh, good.
Yeah,
This is a great time for me to tell you I actually don't like to read.
Okay, well, get ready for 18 slides about stuff.
I am a math teacher, and so when you said, is there a minimum, and I saw like paragraphs forming, I was like, oh boy.
You'll love this story.
I'm going to be like a true math teacher reading through it, and I'm going to be like, and that's what I need, and that's what I need, and that's what I need. I'll read it.
Man, what does that even mean?
You'll love it.
My parents are like, yeah, I'm proud of you. Like, what is that?
My mom loves the air quotes. And I've gotten that from her. She's like, on Tuesday. And I'm like, was it not Tuesday?
Yeah, you're mine.
On Tuesdays. Okay, so like I said, we're going to be simplifying radicals. We're going to look at imaginary numbers. Square root of -1 is I. We'll get to that. Okay, so you might have learned back in the good old days the factor trees. Hey, remember those guys? Welcome back, brother.
Oh,
The factor trees, okay? That's what's happening here. They did a factor tree to reduce this radical. Notice how they found pairs, and one pair of 2's came out, another pair of 2's came out, and then this 5 didn't have a pair, so it stayed inside the house. And they just did 2 times 2, which got me 4 root 5, okay? Some of us know our perfect squares. 4, 9, 16, 25, 36, 49, and so on. Okay, 64, 81, and 100. Okay, some of us know our perfect squares like no problem. So if you're one of those, you can find a perfect square that goes into 80. There is a property that says if I'm multiplying inside of a radical, I can split it into 2. So then the square root of 16 is 4. And I have the square root of 5. Or there's another method that I used to teach my Algebra 1 kids, and I called it a ladder, okay? And this is helpful for when we get to cubed roots, 4th roots, 5th roots, 12th roots, it doesn't matter, okay? So this one is very similar to the factor tree, but we're using prime numbers. And what I mean by that is prime numbers are the only ones that are divisible by itself and 1. We usually don't go past 13. Okay? So with that being said, if I take 80, if I didn't have a calculator or a cell phone, then I know personally I can divide by 2 like that. I can divide by 3. I can divide by 5. That stuff I can do in my head, okay? So for example, if I'm looking at this and I say this, if I'm looking at 80, automatically I know, oh, that's divisible by 2. And then I can do this quickly. And when I get to my stopping point, I've hit another prime number. Okay, now I did do that really quickly. But all you're asking yourself is there a number up here that goes into 80? Well, automatically I know 2. So I got 40. I can keep going. Divide that by 2, I get 20. Divide that by 2, I get 10. Divide that by 2, I get 5. All right? So then I have one pair of 2's. That comes out because it's the square root. Okay, another pair of 2's. And then I always say, this 5 doesn't have a date. It's got to stay in the house. Or number 5. Okay? So then I can simplify from there, and I can say this is for square root of 5. be different methods. If you learned another method in any of your other classes, go for it. I don't care how you do it. But that's just another way, because then if we get to doing maybe the cubed root of 80, instead of finding pairs, 2 of a kind, because of the square root, I would just find 3 of a kind. So then it would just be 2, the cubed root of 10. We'll just multiply what's left over kind of thing. Okay? So, and we'll get to that in a whole nother section, a whole nother chapter when we get to cubed roots. Okay? So, whichever method you prefer, go ahead and reduce square root of 30 and the square root of 40. Remember, your prime numbers are 2, 3, 5, 7, 11, 13, 17. We really don't go that far, but just so you know. Okay, so if I look at the square root of 30, I'm a perfect squares person. I'm thinking of 4. 4 doesn't go into 30. I'm thinking of 9. 9 doesn't go into 30. I'm thinking of 16. 16 doesn't go into 30. So I don't think a perfect square goes into 30. I don't know if I trust myself on that one. So then let's say I want to divide. I can divide by 2, that gets me 15. I can divide by 5 or 3, it doesn't matter. No matter what you divide with, you're still going to have the same numbers on the outside. I could have started this whole problem with 3. You notice? I'm still going to get 2, 3, and 5. No matter what combination I do. I will get a 2, I will get a 3, and I will get a 5. Okay? So it doesn't matter which one you want to start with. Do I have any pairs? No. This cannot be simplified. So your answer is just going to remain the square root of 30. It cannot be simplified any further than that. Okay? If you were a prime factorization person, you would have had 5 and 6. And then 2 and 3. You don't have any pairs, okay? If I look at 40, I can divide by 2, I get 20. Keep going, divide by 2, I get 10. I can divide by 5, or I could have divided by 2. It doesn't matter. Do I have a set of 2 of a kind? Yep, I have 2 2s. That was supposed to be green. There we go. And then I have a 5 and a 2 left over that don't have any pairs. They just get multiplied on the inside. So 2 root 10. Okay? My perfect squares people out there would have been like, I see 40. I know 40 is divisible by 4. 4 is a perfect square. So I would have said the square root of 4 times the square root of 10, which gets me 2 root 10. Okay? Smaller numbers are a whole lot quicker with perfect squares, but you Y'all, stuff happens during tests. Okay, I know it does, and it's something in your mind where you're like, I don't even know where to begin. That's why I teach this way. So that way I know I can divide. Okay? I know I can easily divide by 2s. I can divide by 3s. I can divide by 5s. Okay? And then I can find 2 of a kind, just like as I was playing cards. Okay? But whatever method you prefer, go for it. Okay? Let me make this bigger. Try these 4. All right, so if you're a perfect squares person, the first one you would know, 25. 25 goes into 50. I can rewrite that as the square root of 25 times the square root of 2, which just would get me 5 square root of 2. If you are dividing, then it doesn't matter what you start with. You could have started with 2. You could have started with 5. Either way, you have a pair of 5s and a 2 left over. Either way. 27. My perfect squares people might say, aha, 9 goes into that. So I could do the square root of 9 times the square root of 3. So 3 square root of 3. My division people would divide by 3, we get 9. Divide by 3, we get 3. I have 1 pair of 3s, 1 left over. Hopefully everyone recognizes the square root of 36. If not, if you started dividing, which is totally fine, you would realize that you have a pair of 2s and a pair of 3, but nothing left over to stay in the house, so we don't write the square root anymore. And lastly, this one's new. We do know what the square root of 4 is, but that negative in there, that's what we were learning when I put the square root of -1 equals I. So with that being said, Just like I can write these out separately here, I could, just to show my work, write this out separately as well. And we learned that the square root of negative 1 is I, and the square root of 4 is 2. I want y'all to write these kind of like variables. I also want you to write them with like a little tail with them. Just because you tell me, is that 21? Is that 2I? Or let's say I'm really getting after the work. Is that 2 to the first power? I don't know. Okay. So if you do this little hook right here, it shows me that that means I. Okay. Just so I don't have to guess what your work is. Okay. Some of y'all like to do the cursive I. That's fine. But just so I know that it's not a 1 or an L or anything like that. Okay. Do I have to show this every time? No. If I start to look at this and I see a negative underneath a radical, I'm going to deal with my square root like I always do, and then I'm just going to tack on an I at the end. Pretty straightforward. Okay? All right. So, we talked about square root of negative 1 being I. I is an imaginary number. I squared is negative 1, because if you think about it, you square a square root, kind of cancel each other out there, okay? So if I, and then I squared is negative 1, we're going to continue this pattern on. Okay, so let's derive this pattern. And what I mean by that is I can ask you the question, what is I to the 438th power? What? Okay, that seems a little wild, but it's doable, okay? So there's a pattern that goes along with this. So I, we've already talked about. That's the square root of negative 1. We have I. I squared, we've already said if we had the square root of I, or square root of negative 1, sorry, the square root of negative 1, then we just get negative 1. Okay? Trust me when I say those are the two main ones you're going to use. What does I equal? That's the square root of negative 1. What's I squared equal? That's negative 1. Okay? Now, I cubed, let's use our exponent properties instead of writing the square root of negative 100 times. Okay? I cubed is the same thing as I squared times I, right? I've got 2 from the first one and then a third one, so I cubed. What is I squared? Negative 1. So this just becomes negative I. Also a disclaimer, once you know the pattern, you won't have to derive it. Okay? So if you're like, I'm so lost right now, in the back of your mind, say, I need to put this pattern in my one-sheeter that I'm doing later, okay? I to the 4th, I can say I squared times I squared. I could do I cubed times I. It doesn't matter. But if I do I squared times I squared, what's I squared? -1 times -1 is what? Okay, I to the 5th. I can do I to the 4th times I. I can do I squared times I cubed. It doesn't matter. If I do I to the 4th times I to the 4th we've already discovered was 1. And we get I. Notice how we started from the beginning again. If I did I to the 6th, I'd get -1. If I did I to the 7th, I'd get -I. So the 4 you have to remember are the top 4 right here. That is your pattern. I, -1, -I, 1. I, -1, -I, 1. Okay? That is your pattern. I would put that on that sheet for those of y'all that really helps you for this last test. I would put that pattern on there. Okay, so during a test, I have fight or flight, don't know what I'm doing. I remembered the pattern because I did study that, but I didn't know the shortcut. If I wanted to know I to the 23rd power, okay? Nothing is stopping you from going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Nothing is stopping you from counting. Now you have to know the pattern before you can count. Okay? But what seems easier than counting? Dividing by what?
I like the numbers and seeing which one gives you whole numbers.
Okay, but what are we dividing by? Notice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4. Okay? If you divide by 4 and then just count your remainder, your life's a whole lot easier. So for example, I know 4 goes into 20. And there's 3 left over. So then I can go 1, 2, 3. -I. Okay? I can give you I to the 44th power. Well, I know 4 goes into that evenly. It's just 1. Okay? But any remainder that's left, you just count from the top down. So if I say I to the 17th, I know it goes into 16 with 1 left over. I is my answer. Okay? Now, nothing is stopping you from counting all day long. Okay? Just know that there is a shortcut. Okay? So let's try some more examples. Go ahead and try these 4. If you want, put the negative that's in front of these 2 problems, you can write them out like that. Then once you simplify, you can multiply by -1. Go ahead and try those out. try not to use the calculator. And I'll tell you why here in a little bit. All right, so if I look at I to the 87th power, so I could count 87 times. That's fine. Or I can say I know 4 goes into 87, or 84. 4 goes into 84 with 3 left over. So all I would have to count is 1, 2, 3. So my answer is just negative I. What did y'all get for I to the 64th power? 1, because 4 goes into it evenly. Okay? I to the 18th. I know 4 goes into 16, 2 left over. 1, 2. But then negative 1 times negative 1 is a positive 1. Okay. 27. 4 goes into 24 with 3 left over. 1, 2, 3. And we just get I. Okay. So your calculator has an I button. That's why I said if you find yourself using the calculator, it's right there for you. It's second decimal. So I could technically do second decimal I to the 64th power. And it gives you E. But remember, if it's E, that's basically the same thing as 0. So then there's your answer, which is 1. Okay. And your calculator does all that for you, but that's why I'm trying to keep y'all away from doing that. Okay. So this particular slide is how am I going to write my answers? All right. We've already looked at how to reduce radicals, but now we have the imaginary numbers with it. Can you reduce the square root of 10? Is there a perfect square that goes into 10? No. If we're dividing, 10 divided by 2 gets me 5. Do I have any pairs? No. So to write this simplified, we would just write our I square root of 10. So I have you write it in front because anything with a square root how did I know? Well, that one you saw me do it, but how would I know you just didn't get really square root happy, okay? And just kept drawing it. Is that I under the radical? Is it not? That'd be weird if it was. What's going on? So that's why I always have y'all put it in front, okay? Square root of 36, again, we're just going to treat this as if it is a variable. We wouldn't write x6. So we write 6x. Same thing, we'll write 6i. And on number 3, we've already reduced the square root of 27. What did we get? 3 square root of 3. But since I have that negative in there, this is how I want you to write your answer. You're just going to do 3i square root of 3. So your I is going to go in between your constant, or your coefficient, sorry, and your radical. Okay, so this is more so how do I write my answers? Okay. Any questions on those? Okay. Let's talk about complex numbers. They really aren't that hard. I might say they're not complex. Okay. But when you're looking at these particular numbers, your real number has to come first. Okay? That's why this is standard form. Just like you have standard form of a quadratic. Okay, this is standard form of a complex number. You always put your real number first, then your imaginary number. Okay? So if you're on a test and you get down to your answer and you have 4i plus 2, you have your imaginary number first and then your real number. You just need to flip-flop them. So you would just write it out 2 plus 4i. The standard form, we have a plus bi or a minus bi. Okay? Now, this is something that's kind of thrown into the curriculum as like, hey, you need to make sure they know how to do this. But then you really don't use it until pre-cal. Okay? And I'll show you how we'll use it in pre-cal. But it looks very confusing, but let me tell you, it is super simple. All right? If this is your real axis, this is your imaginary axis, and I want you to plot the point 1 plus 5i, I go to 1, and I go to 5i. And I plotted that point. I mean, I know y'all can't see my facial expressions. It's so weird, but yeah, it's as simple as that, okay? If I have negative 5 plus 2i, negative 5 plus 2i. Again, if I didn't show you this, you would be like, this is probably the hardest thing I'll ever see. But then showing you, y'all are like, okay, next. Okay, so negative 4 minus 2i. And lastly, 2 minus 5i. Okay, so why would that help us in pre-cal? So you're going to be changing a complex number, what we got here, to a trig form, okay? So you're going to go from imaginary complex number to trig form of a number, okay? So what you're doing when you plot these is you are creating a triangle. And that's what you'll use in pre-cal, okay? But if I give you these numbers, which I would teach it anyways over again, but if I give you these numbers, you would know first thing, I have to plot that point. Well, how do I plot that point? You have now learned, okay? So it is as simple as that. You literally just plot the point. Almost consider your new XY as your AB, okay? All right, moving on from that. This is what I'm going to encourage you not to write all this down. And what I mean is the next slide. If you want it, this is being recorded. It will be on your Canvas page, or it's in your book, but it makes life a whole lot more confusing, okay? Look at all those variables. That's so nice. On these variables, they're like, hey, let's make this as abstract as possible. Let's throw all these variables in there, and then we'll tell them, hey, by the way, it just means this, okay? So when you have two complex numbers that you are adding together, you're going to add the real numbers and then add the imaginary numbers. Ooh, okay. I don't know what else, why this is why they want to show you that, okay? This is a lot of variables for something so simple. AKA, you're combining like terms. Remember pre-algebra? The good old days? Like, even before Algebra 1, when they're like, here's X, just combine it with another X, kind of thing. That's what we're doing here. The only way you can really mess these up is if we're subtracting and you forget to distribute your negative, okay? That's what happens. Another way, I don't know what it is, but y'all have a red flag that goes off when you see two sets of parentheses. Your mind goes to FOIL or double distribute. Always. This will pop up on a test, and y'all will multiply these together. Because it's just natural. I see two sets of parentheses. I gotta start FOILing, okay? So that's why you don't see me. Some teachers will go, okay, so I just need to combine these together. Oh, that really sends off this is FOILing, okay? So I just like to draw lines underneath, say 7 and -3, give me 4. And -2i and a +1i just gets me a -1i. All of those variables just to say that, okay? If you want to write some notes with it, I would just put add your real numbers together, add your imaginary numbers together. AKA, you are combining like terms. The only way you can mess these up is if you have like a little brain fart and you're like, man, you know what? 7 - 3 today is going to be 7. I don't know. Or like the clock back there that, has anyone ever had Miss Fraybold as a teacher? I'm so glad this is on my recorder. Yeah. So we were sitting in here the first 3 weeks when we're working on stuff. She looks back there and look up at 12. It's 6 times 2, right? But she looked at it and she was like, 6 - 2 = 7. This clock is so stupid. And so then we were like, and then she goes, oh, wait. That's a multiplication sign. I get it now. And we're like, no. Let's go back to the fact that you said 6 - 2 was 7. Like, there's no way you could, like, weasel that around that gives you 7. So, I had to put that underneath there. But, yeah, she was, that was something special. Okay, so, things happen, though. She's an English teacher. I'll give her that, but. Okay, try these 4. Like I said, if you were on your homework or anything like that, what I would probably do, especially if they're all jumbled together, is I would acknowledge what the sign is in between each thing. Because I don't want to multiply if I don't have to multiply. And I don't want to forget if it's a minus sign. Okay, that is a quick way to make little errors on these problems. So if you're at home and you want to check answers, remember there is an I in your calculator, but this is strictly just to check. I want y'all to know how to do this without a calculator, especially when it comes to test or state test time. I want y'all to still know how to do a lot of this stuff. So if I just enter this in exactly how I see it, remember, this is not how I want you to do your homework. I just want you to be able to check it. But if you enter it in exactly how you see it, it will do it for you. Okay. So there's actually a lesson in pre-cal that I teach. It is complex numbers. And I say, hey, guess what? You passed Algebra 2. Congratulations. Now you're in pre-cal. I need you to be able to just use the calculator to do this stuff quickly. And then I don't teach that day. I just let them do their homework that day because it's just in the calculator. But it's something that needs to be refreshed kind of thing. So, which in pre-cal anyways, the first 3 chapters is Algebra 2 anyways. It's not until you get to chapter 4 you get into the trig. And chapter 2 is Algebra 2 on steroids. It's literally like how we're doing 3 different chapters and stuff like that in one. So that's what I mean by that. All right, so if we're doing this by hand, 4 and 3 get me 7, and -1 and 2 gives me 1. I would suggest, like I did my Algebra 1 kids back in the day, I would go ahead and distribute my negative and then combine my terms. That way I'm not saying, okay, minus, did it minus, or did it minus plus? It gets confusing. So these actually cancel out, and I just get 7 minus 1, which gets me 6. If you put plus 0i, it's not technically wrong, okay? But you don't need it there. Kind of like you don't walk around saying I'm 16 plus 0. It's weird, okay? So we don't need it there. Again, I'm going to distribute. So then I can just simply combine my terms. So I have 6 plus 2, which is 8, minus 8 means those all go away. And then -9i plus 4i gets me -5i. Okay. And then from there, I distribute. I get 5 minus 3 minus 2i minus 3 minus I. 5 minus 3 gets me 2. Minus 3 gets me -1. And -2 minus 1 gets me a -3i. Okay, so for me, distributing the negative, making it all one line like I did back in Algebra 1 is a whole lot simpler. Okay. Any questions on adding and subtracting complex numbers? AKA combining terms. Okay. Let's take a quick break. And then we are going to multiply and divide.
That's not social distance.
All right, let's go ahead and come back. We're just gonna do multiplying and dividing and then we're done. All right, so multiplying complex numbers, everything was the same with adding and subtracting. We were just combining like terms. But with multiplying, things change a little bit because that I squared. All right, that's the only thing that can be a little bit different. We're going to do the same process as if we were multiplying real numbers, but the I squared, like I said, will get us a little bit of a different answer. So if I have 7i times 3i, so I still have 7 times 3, which is 21, but then I have I squared. And just for note's sake, I squared is the same thing as -1, so my answer is -21. Do I have to show that every time? No. Okay, but if you're looking back on your notes and you're like, how in the world did she get negative? That's how. because of that I squared. Okay. Go ahead and try the next one. Okay. So 7 times 3 gets me 21, times 2 gets me 42. And I can look at this a couple of different ways. I can say, well, I know I times I is I squared, so I know that's going to be a negative, but then I still have an I. Or I could have looked at it and said, okay, well, that's the same thing as 42I cubed. And then I would know, okay, well, what is I cubed for my pattern? It's I, -1, I, okay? And then I would just have to write it in order of what it's supposed to be. -42I. Okay? Again, all their variables, too much. All right? So let's look at number 1. This one's just a simple distribution. Okay? I'm going to take 2I and I'm going to distribute that through. So I get 6I minus 8I squared. So for notes, I'm going to do this one slowly, and I'm going to write out every step possible. Okay? So I'll look at it and I see, okay, well, I squared is -1. But then I know 8 times the -1 there makes this a positive. But then I also know that's not in standard form. So then I'm going to write 8 plus 6I. That is way too many steps, but for note's sake, if you're like, where is she getting these values? How did it just magically change from a positive to a negative or a negative to a positive? Now you have that in your notes, okay? But I'll show you on the next one how I like to do it to kind of save some time and some space, okay? So now we see our 2 parentheses. There's no sign in the middle, so that implies that we are multiplying. So if I have 3I times 2I, I get 6I squared. 3I times 1, let's see, 3I. And I get minus 8I. And then minus 4. Okay. And this is what I would do next, is I would circle the term with I squared, and I'd kind of write off to the side. That becomes -6 because it was a positive, now it's a negative. combine my terms. So -6 and -4 get me -10. And 3 minus 8 gets me a -5. All right. So because I squared is -1, -1 times 6 gets me -6. And then I just combine my terms. Any questions on that so far? Okay, try the next two. And you'll like these because they will turn out pretty. So why do I think these turn out pretty? What happens?
The numbers with I cancel out.
Numbers with I disappear. They cancel out. They go away. You get a real number as your answer, which is nice. Okay? So if I double distribute, again, I'll probably circle that 16I squared with its negative. And kind of right off to the side, that becomes a plus 16. So I don't have to do as many lines there. Okay. And then I notice my middle cancels out. So 4 plus 16 gets me 20. Okay. Same thing over here if I distribute. I notice that I can make this plus 9. These cancel. And 36 and 9 get me 45. So why is it that both of these examples got me just a real number? What do you notice about the two things we're multiplying?
They're the same besides the sign.
Yeah.
One side is multiplication and the other side.
They're the exact same, except for the sign in the middle. So you have 6's here and 3's here. One's a plus, one's a minus. You have 2's here. You have 4's here. One's plus, one's a minus. Okay? What does that mean? That is called a complex conjugate. Weird word, but that's what that is. Okay? And it's on the next slide for you to write it down. But there is a reason why we want to know the complex conjugate, is because we are getting a pretty number, and that's going to come in handy here in a second. Okay, so complex conjugate. Especially when we start solving, if you have A plus BI, you have to have A minus BI. They go hand in hand. You can't get rid of them. They have to be together. A plus BI, your complex conjugate is A minus BI. Just like if I have A minus BI, I have to have A plus BI. They go hand in hand. So 5 plus 4i, I'm going to have, 5 minus 4i. Same thing here. If I have a negative 6 minus 3i, I'm still going to have a negative 6, but it's going to be a plus 3i, okay? You only change the sign in the middle. Everything else stays the same. Okay, so let's look back at the 2 examples we had. There's a shortcut for these. Yeah, and if you don't know it, by all means, double distribute FOIL all day long. Okay, if you notice, what is 2 squared? 4. What's 4 squared? So there's actually a shortcut that you don't have to FOIL when you have a complex conjugate. Okay? All you have to do is a squared plus b squared. Notice how it's just a and just b, not the I. Okay? So if I have 2 and 4, then I would do 2 squared plus 4 squared. Notice how I'm not like, oh, do I take the negative? Do I do this or whatever? Here I take 6 squared and 3 squared. Oh, bless me. I hate sneezing with a mask on. It's so weird. Okay. So 6 squared and then 3 squared, and then we get the 36 and 9. Okay? But if you don't know how to do the shortcut, again, you don't have to. But this is why we learn complex conjugates. All right? You cannot have an I in the denominator. Does anyone know why? Why can you not have an I in the denominator? And this can be kind of a tricky question because some of y'all might have not have been exposed to this in Algebra 1. I'm just seeing if anyone did. Is there something else that can't be in the denominator? 0. Anything? I'm sorry?
Square root.
Square root. Well, what is I?
Square root.
Square root of -1. Okay, so why can we not have I in the denominator? Because we can't have square root in the denominator. But the reason why I say that is because in Algebra 1, they're starting to get rid of radicals in the denominator and reducing it that way. So some of y'all were like, I never saw that. Okay, so how do we make it so there's not an I in the denominator anymore? Well, you just learned about something that makes that disappear. When you multiply it by its complex conjugate, notice how all the i's disappear. That's what we want to do. So when I look at this and I say, I don't want this here anymore, I need to multiply it by its complex conjugate. But I cannot change the value of the problem. I can manipulate it all day long. I can't change the value. So whenever I do the denominator, I need to do the numerator. Because what am I technically multiplying by there? 1. Okay? We're not walking around saying I'm 16 times 1, just like we don't say 16 plus 0. Okay? But we are multiplying by 1 here. The same thing over itself is just 1. Okay? So then now, you just multiply straight across, because that's how you multiply fractions. And go ahead and reduce that for me. You catch on to the shortcut, great. If not, just go ahead and distribute all the way through. So our numerator is pretty straightforward. But my denominator, if I wanted to FOIL, I would know that my middle terms cancel. Negative I squared becomes a plus 1. Plus my 4. I get 6 minus 3i over 5. Now, to be picky, is this in standard form? The answer is no. Okay? And the only reason is it is not a plus or minus bi. And it's picky, like I said. If you want to write it in standard form correctly, it needs to be 6/5 minus 3/5 I. That is 100% standard form. Okay? I want you to be familiar with that because of state testing. I want you to be able to get right what you know how to do, not because you wrote it in the incorrect form. Okay? So this is technically A and then BI. So that's why it had to be separated out. Okay? What about the next one? What can I multiply to get the I to disappear? Up here.
Zero?
No. Can't multiply by 0. What can we multiply by to make that I disappear? Okay, negative 2i is an option. Is there something simpler? Just I. Now, if you didn't know that, that's fine. You'll just do more reducing at the end, okay? If you want to stick to one way or one way only, you would notice over here that I did the complex conjugate. And the complex conjugate of 2i is negative 2i, okay? So if you're like, just teach me one way and I'm going to do every problem that way, multiply by negative 2i. But since there is nothing being added or subtracted with this, to make life easier, I could just multiply by I on both the numerator and the denominator. Why? Because down here becomes 2i squared, which is just negative 2. And I'm going to do it both ways so y'all can see. So this becomes 2i plus 3i squared, which gives me negative 3 plus 2i over negative 2. And then we can write it in standard form. Okay, so let me show you if you did multiply by negative 2. If you're like, I just needed a one way, that's all. Okay, so, and I'll come back to this slide and y'all see it. I've got 2 plus 3i over 2i. 2 plus 3i over 2i. So if you're like, one way only. And so if I multiply by negative 2i, I get 2 times negative 2, which gets me negative 4i squared. And then if I distribute, I get negative 4i minus 6i squared. So then now I just need to reduce from there. So this becomes a positive 6. So 6 minus 4i. And this becomes a positive 4. So there's something I like to call a Dorito chip. Okay. I use it with the quadratic formula, but the Dorito chip means if there are 3 things that are all divisible by the same number, then you can divide them. Notice how I didn't do that on this problem because 6, 3, and 5 have nothing they're both divisible by. Okay? So it has to be all 3 before you can divide. If you didn't know that, you would know once you broke it into standard form. Okay? So if I was to divide that out, I'd get 3 minus 2i over 2, which takes me back to what you got as your answer before. 3 halves minus 1i. Okay. Either way, you just have to simplify more at the end if you did the negative 2 with it. Okay? Go ahead and try the other 2. I know they're kind of, let me see if I can move that. Yeah, move that up there. We'll move this down. All right, try these 2. And these are going to be a little bit more because they're both binomials. And we'll talk about that in the next chapter, what that means. And then these are our last 2 problems. You are only looking at your denominator for the complex conjugate. And it has to be the same thing you multiply both the numerator and the denominator. Your main goal here is to get the I out of the denominator, and if that doesn't happen, you picked something wrong, you'll need to go back and double check. And for time's sake, I'm gonna go ahead and start working through these, but work on your own and then look up when you're done. And you'll notice too, when you check these in the calculator, your calculator does them that way as well. They split them up. If you do plug these in, you can hit math frac, and it gets it changed back as well. Okay. Let me work through this one really quickly. Are 27, 21, and 45 all divisible by the same thing? What are they divisible by? Huh? 3. So if I get negative 9 over 15, I'll still be able to go further with that. Minus 7 over 15. And then I can reduce the negative 9 over 15 as well. I've run out of a little bit of space here. And that should be your final answer. And like I said, this will be posted since it's recorded if you need to check back through and whatnot as well. Okay.